All right, let's jump right in. Today, we're going to pull back the curtain on the technology that, honestly, runs our entire world, but often goes completely unnoticed. We're talking about the tiny, hidden computers that are the secret brains behind, well, pretty much everything. So, let's kick things off with a question.
Seriously, think about it for a sec. A fitness tracker on your wrist, the anti-lock brakes in your car, the coffee machine you just used. On the surface, they have absolutely nothing to do with each other, but they all share a secret ingredient, a hidden piece of tech that makes them all work.
And there it is. The answer is an embedded system. Now, here's the key thing to get. This is not a general-purpose computer like your laptop that can do a million different things. No, an embedded system is a specialist. It's a tiny computer designed to do one single job and do it perfectly from inside a much larger device.
Okay, so let's really dig into what makes these little guys tick. What makes an embedded system so different from the computer on your desk? We're going to look at the core characteristics that define this whole hidden world of computing.
And what's really cool is how these all fit together. First, it has a dedicated task. It's a master of one trade, doing its one job over and over and over again. But, and this is a big one, it has to have a real-time response. Think about your car's cruise control. It needs to react to what's happening on the road instantly. A delay there isn't just an annoyance, it could be a complete disaster. And on top of all that, it's got to be super efficient, cheap to make, tiny in size, and barely sipping any power.
So, if the embedded system is the hidden computer, what's the actual brain of the operation? Let's zoom in even further to the component that does all the heavy lifting. And that would be the microcontroller. This thing is an absolute marvel of engineering. You know how the processor in your computer needs a bunch of other separate chips for memory and all its other functions? Well, a microcontroller has everything it needs on one single tiny piece of silicon. The processor, the memory, the ports to talk to the outside world, it's all there. It's a whole computer on a chip.
This chart really lays it all out. Just look at that first row, components. A microprocessor, like in your laptop, is just the central brain. It needs a whole support team of external parts to function. But a microcontroller, it's the whole team in one package. CPU, RAM, inputs, outputs, everything. And that self-contained design is exactly what makes it so small, so cheap, and so perfect for a dedicated job, like running your washing machine.
All right, so up to now, we've been talking about individual devices, each with its own little brain working in isolation. But what happens when all those little brains start talking to each other? Well, that's when things get really interesting. And that is what we call the Internet of Things, or IoT for short. This is the moment our embedded systems get a voice and a connection to the rest of the world. It's this huge network where physical objects, from your thermostat to a giant factory machine, can gather and share data over the internet, creating this incredible web of smart, automated systems. So how does this whole thing actually work? Well, you can think of it like a four-step journey. First, you have the things, the sensors out in the world collecting data. Next, you have the brains, the processors that take all that raw data and figure out what it actually means. Then you've got gateways, which basically act like your home router, getting that information onto the network. And finally, you have the application, the interface, where all that data gets turned into something useful for you.
Now, for all these devices to chat, they need to speak the same language, right? We call these protocols. And there isn't just one. It's more like a whole toolbox of different languages. You've got Wi-Fi for when you need lots of speed and have plenty of power. But for a tiny sensor out in a field that needs its battery to last for years, you might use something like LoRaWAN, which is slow but can send a tiny bit of data for miles. The whole point is, you pick the right language for the job.
Okay, I know what you might be thinking. This all sounds super complicated, like something only huge corporations with massive engineering teams can do. But what if you wanted to build something? Well, one key player came along and made this technology accessible to pretty much everyone. Enter Arduino. Seriously, this little board was a total game changer. Before Arduino, getting into microcontrollers was really hard. But by creating this simple, open-source platform, they blew the doors wide open for hobbyists, artists, students, and inventors. Suddenly, you could focus on your cool idea instead of getting bogged down in complex engineering.
And don't let the code scare you, because it's actually incredibly straightforward. This is it. This is the absolute bare minimum for any Arduino program. It's just two parts. You've got the setup function, which runs one time right when you power it on. It's where you get everything ready. And then you have the loop function, which does exactly what it sounds like. It runs over and over and over again forever. That's it. That's the heart of your project. So, when you take these easy-to-use platforms, combine them with the power of embedded systems, and connect them all through the Internet of Things, what do you get? You get a smarter world. Let's look at a few examples that are probably all around you right now.
I mean, it starts right in our own homes. Think about smart lights that know when you walk into a room, or a security system that pings your phone the second it detects movement. These aren't just cool gadgets. They're embedded systems making our homes safer and way more efficient.
Okay, now let's zoom out from the house to the whole city. We're talking about smart traffic lights that actually watch the flow of cars and adjust their timing to reduce traffic jams. Or garbage cans that literally send a message saying, hey, I'm full, so collection routes are optimized. This is IoT making our cities run better for everyone.
And this tech is getting really personal, especially when it comes to our health. That fitness tracker you're wearing, that's a perfect IoT device, constantly gathering data. But it goes way beyond that. Think about remote monitoring for patients, tracking vital signs from home, or even a tiny wearable that buzzes to remind you to fix your posture. It's amazing stuff.
And finally, let's talk business. In the industrial world, they call this the IIoT, the Industrial Internet of Things, and it is completely revolutionizing how things get made. Imagine factory machines that can predict when they're about to break and schedule their own repairs, or sensors that can spot a microscopic defect on a product flying down an assembly line. This is boosting efficiency and quality on a scale that's just massive.
So think about it. From the thing that brews your morning coffee to the massive factories that build our cars, these hidden computers are literally everywhere. And now, they're not just working alone. They're all starting to talk to each other. We've gone from these quiet, single-task devices to this globally connected network of, well, things. Which leaves us with one final big question. As billions more of these devices come online, what new conversations are they going to have? And how is that going to reshape our world next?